Hi everyone, welcome back to my channel on Engineering Mechanics. Today we'll start with Module 5. Initially, let us see what all are the portions to be covered in this module. It is kinematics of rotation, rotation about a fixed axis, rotation under a constant moment, plane motion of rigid body, instantaneous center of rotation, simple harmonic motion, and spring mass system. Here, some portions you have already studied in your module 4 and some portions you have studied in your higher secondary classes. So, if you haven't started studying module 4, please go through module 4, understand the concepts, and after that only start studying module 5. The link of video lecture on module 4 will be given in the description box. So today we will be dealing with these three sections, which is kinematics of rotation, rotation about a fixed axis, and rotation under a constant moment. Before starting that, before starting the portion, there are some terms which is to be familiarized. You have already studied these terms in your module 3. The term is radius of gyration. So I'm not going with the definition, we require only the equation. Radius of gyration is denoted by the letter small k, that is equal to root I by m or equal to root I by a, where I is the moment of inertia, a is the area of body, m is the mass of body. And again, it is better to say if this is in terms of area, if I is in terms of area, then better to say I as area moment of inertia. And if this I is in terms of mass, then it is better to say as mass moment of inertia. So if it is in the denominator, if it is mass, this is mass moment of inertia. And if in the denominator it is area, then the numerator will be area moment of inertia. Or it doesn't matter, you can say it as in general moment of inertia also. Now again, you might have done many problems on moment of inertia related to area. Here in this module, we will be concerned only with this mass moment of inertia. So this is the equation which you will be doing in many problems. K equal to root I by m. Now mass moment of inertia of some sections you have already studied in your third module. The mass moment of inertia of a ring, of a cylinder, and a uniform disk. You have already studied the equations. Here, in most problems, we will be using only mass moment of inertia of a circular section or uniform disk, both the same, which is equal to mr square by 2, where m is mass of body, r is the radius of circle. So these are the two equations which you should be remembering. Radius of gyration is given by root I by m, and mass moment of inertia is given by mr square by 2. Then either you can substitute this I over here and you will be getting a simplified equation for radius of gyration, which will be equal to r by root 2. No need to increase the number of equations. Just study these two equations. That's fine. Now there is one more term which we left in module 4, which is moment of momentum. So actually this should come under module 4. It doesn't matter. We'll study here. Before starting moment of momentum, what is momentum? We already studied it. Momentum is the product of mass and velocity, that is given by m into v. Now actually what is moment of force? You have studied in your first module. Moment of force means it is force into distance. Similarly, moment of area means it is area into distance. So if a term moment comes, it is just that term into distance. So moment of area is area into distance. What will be moment of area? It is area into distance into distance. If distance is represented by, it will be if distance is represented by r, it will be a r square. Now what is this a r square? That also you have studied in your third module. It is represented by I, it is moment of inertia. So if it is in terms of area, then it is area moment of inertia. Similarly, if instead of this area, if it is mass, that is moment of mass equal to m into r equal to mr square, that is equal to I. That I is termed as mass moment of inertia. Similarly, what will be moment of momentum? It will be momentum into distance. Momentum is mass into velocity into distance r. Now we have already studied the equation connecting linear velocity and angular velocity, that is relation between V and omega, which is given by V equal to R omega. So we can represent this as M into R omega into R, or it is MR square into omega. What is this MR square? AR square we have seen it has area moment of inertia. Similarly, MR square is mass moment of inertia. So this moment of momentum can be written as I into omega. What is this I? Mass moment of inertia into omega means it is angular velocity. So moment of momentum is the product of mass moment of inertia and angular velocity of a rotating body, which is given by I into omega. Moment of momentum is also called as angular momentum. Now let us start the portion. Initially, let us see what are the different types of motions. There are mainly three types of motions. First one is translation, second one rotation, third one combined motion of translation and rotation. These two types of motions you have already studied in your part 1 of module 4. We had some equations and we did some problems also. Anyway, let us see it again. First one, translatory motion. So it can be said as if a body moves in such a way that all its particles moves in parallel plane and travels the same distance, then the body is said to have motion of translation. That is, all the particles are moving in parallel plane and moves the same distance. So consider this link AB. Its initial position is AB. If it has moved to a new position A1, B1, which means A has moved to A1, this distance is parallel to this B1 distance, and this has moved the same distance. So A1 distance is same as that of B1 distance, which means this is a motion of translation. So what were the equations available for translatory motion or linear motion? There were three equations: V equal to U plus AT, V square equal to U square plus 2AS, and S is equal to UT plus half AT square. Now the second type of motion is rotation or circular motion. So that also we know, if a body rotates about a fixed point in such a way that all its particles move in circular path, then the body is said to have motion of rotation. That is, if it is moving in a circular motion, then it is motion of rotation. Now, the fixed point about which the body rotates is called point of rotation, and the axis passing through the fixed point is known as axis of rotation. So there are two more terms, point of rotation and axis of rotation. So the particular point about which the body rotates is called point of rotation, and if there is an axis passing through this fixed point, it is known as axis of rotation. So consider this example itself. There is a link AB. Its initial position is AB. Now if it has moved to a new position AB1, that means this A is fixed, B has moved to B1 in a circular manner. Then it is an example for motion of rotation. And in this example itself, this A point is called as the point of rotation. That is, point of rotation about its rotating. And if there is an axis passing through this point, it is known as axis of rotation. Now, what were the different equations available for rotation? There were three equations similar to this. It is omega equal to omega 0 plus alpha t, omega square is equal to omega 0 square plus 2 alpha theta, theta equal to omega 0 t plus half alpha t square. It is same as that of these equations itself. We have seen these equations also in our module 4 part 1 itself. So instead of v, it will be omega, where omega is the angular velocity, final angular velocity. Instead of u, it will be omega 0. Instead of a, it will be alpha. T is t itself. Instead of s, distance, it will be theta, which is angular displacement. And also, there is two more equations related to that. If rotations per minute is given, that is n is given, n means it is in rotations per minute. Omega equal to 2 pi n by 16 and theta equal to 2 pi into number of revolutions. So these are the equations which we have already studied. By using the same equations itself, we will be solving the problems here also. So in that, the kinematics of rotation, that was the first portion which we should study in this module. These problems are just the same problems what we have seen in the module 4 part 1 curvilinear motion. So we are not doing the same problems over here itself. So just refer those problems. So for problems refer curvilinear motion part 1 module 4. The same problems can be done over here also. So let us see the next heading. It is equation of motion of a rigid body rotating about a fixed axis. So the previous equations are uh, used here also, which is omega equal to omega 0 plus alpha t, omega square equal to omega 0 square plus 2 alpha theta, theta equal to omega 0 t plus half alpha t square, omega equal to 2 pi n by 16, theta equal to 2 pi into number of revolutions. So these equations we have already studied. And along with that, there were two more equations which you have studied in your higher secondary classes. That is equation connecting between linear velocity and angular velocity, which is v equal to r omega. Equation between linear acceleration and angular acceleration. It is a equal to r alpha. Now, along with that, for equations of motion of rigid body rotating about a fixed axis, along with these equations, there are some more equations. Let us see what are the equations. The term is torque. The term is torque or turning moment. Torque is normally represented by T, capital T. It is given by the equation I into alpha, where I is the mass moment of inertia of the body, alpha is the angular acceleration. So remember this equation also. Torque T equal to I into alpha. Similarly, kinetic energy due to rotation. Normally, what was the equation which we studied in your linear motion? Kinetic energy equal to half mv square. Similarly, in rotation also, it is a similar equation. It is half I omega square. So instead of half mv square, it is half I omega square. So here I is mass moment of inertia and omega is the angular velocity. In that case, it was half mass into velocity. Here it is mass moment of inertia into angular velocity. So kinetic energy is half I omega square. Now work done in rotation is, what was the work done? It is force into distance. So here in rotation, instead of force, it will be torque into angular distance. So torque can be also written as the product of force and distance. Torque or moment, turning moment. What is moment? Force into distance. Similarly, moment or torque is force into distance. That is, instead of t, it is force into distance into theta. Now, we have already studied work energy equation over there. So similarly, work energy equation for rotation, same itself. Work done equal to change in kinetic energy. What is the work done? It is torque into theta equal to kinetic energy is half I omega square. So it will be change in kinetic energy equal to half I omega square minus half I omega 0 square. Final angular velocity, here it is initial angular velocity. So these are the equations which we'll be studying over here, and based on this we'll be doing some problems. So these equations are just similar to what we have seen in our linear motion. There are no new equations, just the sign changes or symbol changes. Okay, let us start doing the problems. First problem, a flywheel weighing 50 kilonewton and having radius of gyration 1 meter loses its speed from 400 rpm to 300 rpm in 120 seconds. Calculate the retarding torque on it, change in the kinetic energy during the above period. So what is torque? How to find the torque? Torque is given by equation is I into alpha, where I is the mass moment of inertia, alpha is the angular acceleration. Now how to calculate I? There are two methods for calculating I. For calculating I in the question itself, there may be two types. The first case is they might have given the radius of gyration. So what is the connection between radius of gyration and I? A equal to root I by m. I equal to mk square. I equal to mk square. If it is in terms of radius of gyration. Or in the question it may be given like a section is given like for circular section. So and so. So for circular section we know what is the mass moment of inertia, which is mr square by 2. So either by in terms of radius of gyration or in terms of section. Here it is in terms of radius of gyration. So it is mk square into alpha. Alpha is the angular acceleration. Angular acceleration is not given, but they instead they have given some other things like the initial speed is, that is omega 0 is for in terms of 400 rpm. So what is the connection between omega and rpm? It is omega equal to 2 pi n by 60. So let n0 be the initial, so it is 400 rpm. The next thing is 300 rpm. It changes from 400 rpm to 300 rpm. So n equal to 300 rpm, which is final rotations per minute. Time is given 120 seconds. The weight is also given, which is 50 kilonewton. Convert into Newton. Now to find alpha, we have the equation connecting all these things. Omega 0 t. Omega is equal to omega 0 plus alpha t. In order to calculate omega 0, it is 2 pi n0 by 60. So 2 pi into n0 is 400 by 60. You will be getting this answer. Similarly, omega is 2 pi n by 60. Here n is 300. So from that you will be getting omega value. Now equation connecting omega 0 alpha t is omega equal to omega 0 plus alpha t. Omega value you know, omega 0 value also you know. Alpha is the angular acceleration which is to be calculated. T is 120 seconds. So you will be getting alpha equal to minus 0.087 radians per second square. This minus means it is reducing the speed, which means it is negative acceleration is the retardation. So we have already studied that term in the first part of module 4, retardation. Negative acceleration is called retardation. Now we have retarding torque T equal to I into alpha. You already got the value of alpha. I is mk square. What is m? It is the mass of body. Weight is given as 50 kilonewton. So 50 into 10 raised to 3. What's the relation between weight and mass? M equal to W by G. So it is 50 into 10 raised to 3 divided by 9.81 into K's radius of gyration is 1 meter. So it is into 1 square into alpha value is 0.087. No need to write negative over here. So retarding torque you will be getting 443.43 Newton meter. The unit of torque is Newton meter. Torque means it is force into distance. So it is force Newton into distance is meter. So unit is Newton meter. There was one more part in the question, which was to find the change in kinetic energy. So change in kinetic energy is given by final kinetic energy minus initial kinetic energy, or initial kinetic energy minus final kinetic energy. Only there will be a negative sign, doesn't matter. So what was initial kinetic energy? Half I into omega 0 square minus half I omega square. We know the value of I, omega 0 and omega. The same things will be applied over here also, and finally you will be getting the value is 1956.05 into 10 raised to 3 Newton meter, or it is 1956.05 kilonewton meter. Write the unit along with the answer. The unit for kinetic energy is also Newton meter. Let us see one more problem. A right circular disc of weight 1500 Newton and 750 millimeter diameter is free to rotate about geometric axis and is constantly accelerated from rest to 300 rpm in 20 seconds. Determine the constant torque required to produce this acceleration. So what was to be found out? Torque. Torque is given by I into alpha. So how to find I? Instead of giving radius of gyration, they have given it is a circular disk. So moment of inertia of a circular disk is mr square by 2. M is 1500 divided by 9.81 into r. Diameter is given, which is 750 millimeter. So radius is 750 by 2, 375 millimeter. Convert this into SI unit. So it is 0.375 meter. Just substitute over here. You will be getting the moment of inertia. Now alpha. In order to find alpha, it is given constantly accelerated from rest. So initial velocity, initial angular velocity will be 0 to 300 rpm. That is n value is given. So relation between omega and n, omega equal to 2 pi n by 60. Substitute n equal to 300 over here. You will be getting omega value. And t is also given. So connecting all these things, you will be having equation omega equal to omega 0 plus alpha t. So from that you will be getting alpha value. Substitute over here, and finally you will be getting the torque. So there is one more portion in rotation. We'll see it in next part of video lecture. So that's all for today. Hope you understood it. Apart from the previous equations what we studied in module 4, there were few more equations like torque equal to I into alpha, kinetic energy equal to half I omega square, work done equal to torque into distance. Now, there were some comments for the first part of module 4, like it's difficult to read. So the reason and solution for that was also commented in the comment box and description box itself. We did this video in a different manner. I think this will be more clearer than the previous parts. If still there are some issues relating to clarity, please do comment early itself. Then only those things can be modified in the next part. Also subscribe and press the bell icon for getting the notification of new videos. Thank you.